Okay, so in the last section we looked at what to do when you are simplifying trig equations, but they were mostly just substituting in terms of sine and cosine. And this time we're going to look at some other strategies. Be sure you show all the work, and remember you need to memorize your identities. Okay, so we're going to look at these 4 questions under number 4 of your Using Trig Identities worksheet, page 2. I'm going to put one on a page because I'm going to need space for this. So in the directions it says, if necessary, multiply or divide to rewrite each expression and check to see if any Pythagorean identities apply, then simplify. Okay, so on part A there's nothing to multiply because we don't have any parentheses in there. But if you will look at the top part, sine squared plus cosine squared is a Pythagorean identity. And we know that sine squared plus cosine squared is equal to 1. So I'm going to take this part out and I'm going to make it equal to 1. So now I have 1 plus cotangent squared theta over cosecant of theta. Okay, and then if you look at the top, that is also part of another Pythagorean identity. 1 plus cotangent squared is the same thing as cosecant squared. So we're going to replace this. Okay, so we're going to put cosecant squared. How do you know to use Pythagorean identities? Well, if you have things that are squared, then that would be something you would check. If you don't have any squares in the problem, then you're not going to use Pythagorean. Okay, so now we have cosecant squared over cosecant. And if you'll think back to algebra, when you had x squared over x, you had to subtract the exponents, which is an understood 1 on the bottom. So 2 minus 1 would be x to the first. So we're going to end up with just an x to the first. Well, the same thing happens with cosecant. So if I have squared on the top and I don't have an exponent on the bottom, so it's understood to be 1, I subtract those exponents and I will come out with cosecant. Okay. So that's how we would simplify on the first one. Remember, Pythagorean identities, you can key in. If there are things that are squared in the problem, you're probably going to look for a Pythagorean identity. Okay, now let's look for part B. We don't have anything squared, so Pythagorean is probably not going to help us right now. It may later, but for right now it's not. So again, another thing you should always try to do is, if you've got 4 different functions, we have sine, cosecant, cosine, and secant. Let's try to change everything to sines and cosines. Okay, so cosecant, I'm going to leave sine alone, but the cosecant on the bottom, we have a reciprocal identity for that is 1 over sine. So I'm going to replace cosecant with 1 over sine. Okay, and then I'm going to do the same thing for the secant. Cosine is fine, but for secant, let's replace that with its reciprocal identity of 1 over cosine. Now, I can't add fractions like that, and they're complex fractions. I have a fraction in a fraction. So I need to do a little simplifying. So remember, we're going to take the bottom and flip it over. So I would have sine of theta times sine over 1. Okay, and this first one is really sine over 1 also. Sine times sine is sine squared. Okay, let's do the same thing with the second fraction. So I have cosine times, instead of 1 over cosine, I'm going to flip it because division, you're going to flip the second fraction. So cosine over 1 times cosine over 1 is cosine squared. And I forgot to write my plus sign in the middle. Okay, so it should be sine squared plus cosine squared. Okay, now we have things to the second power. So now we can look at our Pythagorean identities, and sine squared plus cosine squared is equal to 1. Okay, so sometimes with fractions, or if you have lots of functions, it's best to change things to sine and cosine. And with fractions, also remember you've got the common denominator strategy to add fractions. Okay, for part C, the parentheses on the top. We know that parentheses mean to multiply. And when you've got 1 minus cosine times 1 plus cosine, We need to FOIL this just like we would if it had x's and other numbers in there. So let's use our FOIL strategy to multiply. First times first, 1 times 1 is 1. Outside times outside, 1 times the cosine is just cosine. Okay, inside times inside is negative cosine times 1, or negative cosine. And negative cosine times positive cosine, negative times positive is negative. Cosine times cosine would be cosine squared. Okay, notice I'm showing every step as we're going. I'm not doing work in my head, and you should not do work in your head either. I need to see all of your steps. Okay, now look at the top part. We can simplify a little bit because we've got a plus cosine and a minus cosine. So those will cancel each other out. So now we've got 1 minus cosine squared over sine. Okay, and we can simplify a little bit more on this because 1 minus cosine squared, we have a Pythagorean identity that says that sine squared is plus cosine squared is equal to 1. But if I rearrange that a little bit, if I take this cosine to the other side, since it's positive, I would end up subtracting, which would give me 1 minus cosine squared. So 1 minus cosine squared is equal to sine squared. And if I have sine squared divided by sine, subtract your exponents, and we will end up with sine of theta for an answer. Okay, one more question that we're going to look at for today. Okay, and again, this will take practice. You don't get good at this just by watching me do it. You're going to have to practice some on your own and make mistakes and learn from them. Okay, so we're going to start with this part right here, sine plus cosine squared. Okay, and again, we're going to have to FOIL, and we're going to write it out. Sine plus cosine times sine plus cosine. Okay, so first times first, sine times sine is sine squared. Outside times outside would be sine times cosine. And I can't really do anything there, so I just write it as sine cosine. Inside times inside is sine times cosine again. It doesn't matter what order you write them in if you're multiplying. And then last times last, cosine times cosine is cosine squared. Okay, and all of that right now is over cosine. Okay, now we've got a lot of stuff on the top, but there is a little bit of simplifying that we can do because if you look at these two terms in the middle, they're the same. And remember that if there's no coefficient, it's like having a 1 there. It's just like if you had an x plus an x. So I'm going to put those together, and now we have sine squared plus, I'm actually going to rearrange a little bit too, and I'm going to write the cosine squared next, plus 1 sine squared, or 1 sine cosine plus 1 sine cosine is 2 sine cosine. Okay, all of that over cosine. Okay, so it's a little bit shorter, but there's still more that we can do. So look, we've got some squares in the problem now. We've got two terms that are squared, and this is the reason that I rearranged. What is sine squared plus cosine squared? Well, that's our Pythagorean identity, and we know that that equals 1. Okay, so I'm going to change this part to 1. So now I have 1 plus 2 sine cosine. And I actually forgot something up here at the top because I was running out of room. I forgot this minus 1. So I should have had a minus 1 on the end of all of these terms. So I'm going to put the minus 1 in over cosine. Okay. Now, what's going to happen with your 1's? If I have a 1 minus 1 on the top, those will cancel each other out. So now I have 2 sine cosine over cosine. And since everything on the top is multiplied together, I can cancel the cosine from the top and the bottom. If there was a plus sign in between those, I would not do that. But since it's all multiplication, I can cancel the cosines. So my answer then is going to be 2 sine of theta. Okay, and again, you're going to have to try some of these and make some mistakes before you get good at this. Okay, so if you see things that have parentheses, try multiplication. If you see lots of functions, more than just sine, cosine, or more than 2 functions, then you probably want to change things. Look for identities you can substitute. And if anything has squares on it, look for Pythagorean identities that you can use to substitute. We will do number 5 that's on the bottom tomorrow. Okay, so for now, you're going to take these notes and see if you can use some of these principles to work on trig worksheet number 2.